Yesterday we were talking about all these different types of reactions. Okay, we were talking about combination, decomposition, single replacement, double replacement, and combustion. Okay, 5 different types of reactions. We talked about how to write formulas for combination and for decomposition. Now today we're going to do single replacement reactions. Okay, in a single replacement reaction, you need to look at the back of your periodic table and find this little chart here that is in the upper right hand corner of your back of your periodic table. Org. Okay. This is called the activity series of metals. It's really the activity series of elements. But the first part is the metals. Okay? And the last 4 or 5 at the bottom are non-metals. Whenever you see a single replacement reaction, you must look at that chart. So right above it right now, 4 single replacement reactions. 4SR or something. Get out your periodic table and write it. You have your periodic table? Where is it? That's not going to help you. You need this one. That one doesn't have the stuff on it. Okay? So write SR above it, something, but you need to look. As soon as you see it single replacement, look at this chart. Okay? You have to look at this chart. So we're going to predict products from a reaction.
I didn't want to vote on this anyway.
Sauce, he's got cross.
Okay, so you look at the reaction and you determine it's a single replacement reaction. What do you do? What do you do if you notice it's a single replacement reaction?
Look at your chart.
Look at the chart. Look at that chart. Look at this chart. As soon as you notice it's a single replacement reaction, look at the chart. Okay? It's the first thing you do. So we look at this reaction and we say, oh my gosh, it's a single replacement reaction. Yay! When you look at a single replacement reaction, you've got to see what the single element is. Okay? You have to look to see what the single element's going to be. In this case, what's my single element? Copper. It is copper. Copper is my solid. And then we have aluminum chloride. Aluminum chloride is going to be aqueous, which means it's dissolved in water. It's soluble, yes. Now, before I can do anything else, I say, okay, copper is a single element. I find that single element on my activity series of metals. Where is copper? Down towards the bottom, down there. Copper is beneath aluminum on this chart. Here's aluminum. Because copper is beneath aluminum, it cannot replace it. So basically, this chart tells us how attractive or reactive these elements are. Lithium is the most reactive, then potassium, calcium, sodium, on down to silver. Copper is less attractive than aluminum. Therefore, it can't butt out aluminum. It's like aluminum chloride is hanging out at a club. You know, they're dancing at a club, having a good time. In walks copper. I'm going to snag me that chlorine tonight. And it goes up and says, come on, chlorine, let's go. And chlorine's like, seriously, dude? Really? I'm with aluminum. Much more attractive, much more reactive. Why would I go with you? And poor little copper just walks back away again. And what happens is there is no reaction. Nothing happens.
Disrespect.
Yes. Single elements have to be above the one in the compound, and copper is not above aluminum. So nothing's going to happen. I know. You kind of relate, don't you, Trent?
I don't know what that feels like.
We all laughing. Does that make sense, yes? Now if I go the other way, so aluminum's the single element,
Oh, this me right here.
okay? Aluminum is there and copper is down here. Now copper 2 chloride is hanging out on the dance floor, and in walks aluminum. Little swag. Says, come on, chlorine, let's go. Chlorine's like, oh my gosh, he picked me, he picked me. And chlorine's like, yay. And then poor copper is left all by himself again. Does that make sense? Yes? Okay. So, now, aluminum can replace copper, and the two metals switch places. Does that make sense? Yes? So, when you look at this, let's look at a different one here. Org. Saw me or not. Okay, so, it did see me. So if I have something like magnesium bromide plus nickel. Can nickel replace magnesium? Look on your chart. It's a single replacement reaction. Look on your chart. Is nickel above magnesium?
No.
No, it's not. So it would be no reaction. Okay? What if I had, if I one actually works, let's see, manganese hydroxide plus sodium.
Yes.
Yes. So, when I bring them together, and remember, the sodium replaces the metal. Okay? You cannot have Mn and A together. You can't have two positives. Two metals cannot be together. Okay? So, it's going to be NaOH plus Mn. You see why I did not bring the 2 over with the OH? Because sodium's plus 1. Does that make sense? Now if I have this, Ki plus Cl2. Now you gotta look at the bottom part of that table. Can chlorine replace iodine? Yes, chlorine can. So it's going to make potassium chloride plus iodine, because chlorine's a non-metal, it must replace the non-metal. You cannot have ICl together. Does that make sense? Now I want to show you this back here. My pants keep falling down, sorry. I want to show you the aluminum and chlorine back here, aluminum and copper. So, I have some aluminum chloride, like it was in that first. They're going to the club. Now, so it's solid. Now I'm going to make this an aqueous solution by adding water. Right now it's a solid. I add water, just like making Kool-Aid almost. I don't drink this. And now it's becoming aqueous. This is what an aqueous solution is. If I can get this thing to dissolve. It's just dissolved in water. It would not taste good at all. It'd be terrible, actually. Okay. Then I take some copper. Put some copper in here. And let's watch it react. Anything happening?
No.
No. Copper cannot knock the aluminum out. It can't do it. Copper is not as attractive as aluminum is. But if I take copper 2 chloride, so now I got copper chloride. Oops. Make an aqueous solution out of this. Adding some water to it. Notice what color it is? Copper 2 chloride, so it's going to be what color? Blue-green. Okay. Now I'm going to take some aluminum. Yeah. Aluminum. Stick it down in there. What do you see happening?
It's fizzing.
It's fizzing. So it's fizzing. What do you see growing on it?
It's red.
Whoa.
Red. And what's that red stuff you think?
Copper.
It's copper. The aluminum is kicking the copper out of solution, and it's taking its place.
That's the reaction.
Okay, and that's a reaction. And it'll do it until all the copper is out of solution. And because it's much more reactive than the copper is. See all the copper floating around? You see it? You did. You pulled copper out of, you exchanged copper for aluminum. Which is why they thought, they could make lead into gold or things like that. They were thinking, we can change it from one thing to another, but no. Copper was there the whole time. It was just caught up in something else. So if gold was in there, yeah, you could pull the gold out, but gold's got to be there to begin with. It's not coming out of nowhere. See, more aluminum in there and make it finish reacting. Oops. Ethan is not amused. Feel it now. It's hot. It's an exothermic reaction. This is the same reaction you did the other day in class. Without all the acid.
Yeah. Is it hot?
Yep. I'll just put your hand around it. Okay? So it shows you that, if they don't react, one doesn't react, one does. This is the activity series in action. Okay? Yay. Okay, so we go back up here. Now, ooh, there it goes. That was kind of fast. Okay, so as soon as you notice it is a single replacement reaction, you've got to look at that table. Okay? If you don't, got a pretty good chance you won't get it right. Okay? Look at that table. Now, let's give it a try. Which of the following is more reactive, sodium or zinc? Give me the fingers. So, give me the fingers. Fingers up. Sodium. Good. What is more reactive, copper or lead? The lead. Good. What's more reactive? Yeah. Magnesium or nickel? Look at what you think. Okay? 1. Good. So, will copper replace zinc? Yes or no? Will copper replace zinc? No. No, it won't. Can hydrogen replace aluminum? Yes or no? No. Can potassium replace lithium? Nope. 9. Nope. Can't happen. Okay, so single replacement reactions are when one substance will replace the other and another one comes out of the solution. Okay? And what you're going to be doing today in class, in lab I should say, is this. This is like a little demonstration that kind of shows you. Oh, the flash. Yes, yes, yes. So if you look at this, you're going to be taking metals. You're going to have copper, magnesium, zinc, and silver. Let's just do the magnesium for now. And here's this is magnesium nitrate, zinc nitrate, copper nitrate, and silver nitrate. So we're going to put pieces of the metal into liquids. Okay? Then we're going to remove the little piece of the metal. And you're going to look to see if anything deposits on there. Is there any reaction between the two? Well, obviously magnesium with magnesium should have no reaction. But zinc reacted, copper reacted, and silver reacted. If we do it with copper, put the strips in, and only silver reacts. Does that make sense? So that's kind of what we're looking at here. No, I don't want to do it again. No, 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 no. 9. Okay. There you go. So, what we're going to do is this. I'm not going to do that. Okay, anyway. So let's look at this here. We're going to practice this. Lights are coming on. So, 1, 2, 3, 4, 5, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5. So let's work on this for a minute. It won't take too long. There we go. I'm going to pause this. Oh, there it is. So, in lab, in the table, when you put together the copper with the lead-2 nitrate, if it turns, say, maybe black color shows up, maybe the liquid turned white or gray, something like that. Obviously it was different amount. Tell me what you see, okay? If there's no reaction, just write it in the box. And that'll be fine. Okay? So when you go back to lab, what you're going to do is this. Take you with me. Come, little one. It's rotating around. Feels so weird. Okay. So what you're going to do. Hit that. I can see it now. Okay. These are your spot plates. Okay? So the first thing I do is get a Sharpie and write on here A, B, C, D, E, F. So write your A through F on here. Then go over and get, whoop, I lied, run this side. Always put me the other way. Get 5 pieces of copper. 1, 2, 3, 4, 5. Now you don't have to start with copper. If you want to start with something else, you can do that as well. Okay? It's on. Okay. So we're not going to use A because copper is with copper. So I'm going to put in B, C, D, E, and F. I'm going to, on the first page, describe what copper looks like. Okay? Then I'm going to walk over here, and I'm going to go through each of the aqueous solutions. So I'll put a little bit of lead-2 nitrate on this one, a little bit of zinc-2 nitrate on this guy, just enough to cover it up, a little bit of tin-2. Silver nitrate. Now remember, when you're using the silver nitrate back here, this is the stuff that'll turn your skin brown, and your clothes brown. If it gets on your clothes, it will never come out. If it gets on your skin, you'll have to wait till your skin wears off. Okay? And a little bit of magnesium nitrate. Then take it back to your station and let it react. Give it a few minutes. So sit it down. In the meantime, get a couple pieces of paper towel. One paper towel is going to be for the reacted metals, so you just throw it all away at once. And the other one's going to be for non-reacted metals, because I want them back if they don't react. Get a pair of tweezers out of your basket, and then just look at them. You may have to turn them over because they're floating, so they might just be reacting on the back side of the piece of metal. So look at it. Not reacting, yeah, like this. And just note what's going on. And then, ooh, that's pretty, reactive. And then look at them, write down your observations. Pour this liquid down the drain, rinse it off. Rinse it with some distilled water so we don't get any ions. And go on to the next one. Okay? When you're done, if you would do me a favor, dry off the plate here. Come over to this area. I have a bunch of acetone in this bottle right here. Get some acetones, like the really strong nail polish remover. And clean off your spot plate. Get rid of all the excess color that you put on there. Okay? So it'll just come right off. But just make sure it's back to being no color on it. Okay? We'll finish this tomorrow. You won't finish it today. But take your time. Make sure you make good observations. And have some fun. Okay?